All right, in this podcast, I want to go ahead and prove another identity, whereas we might have to use one of the double angle identities that I have shown on the right here. So given this identity, I want to prove that left-hand side is equal to right-hand side. And the first thing I want to do here is see if we can rewrite each of these trig ratios in terms of another. So for example, cotan 2x, even though it has a double angle, you could still apply a quotient identity here. So remember, cotan is the same thing as cos 2x over sine 2x. So just as long as the arguments, meaning the angles, are exactly the same as the original, so it had to be a 2x, you can go ahead and apply that identity. Looking at the right-hand side here, cotan x will be cos x over sine x, minus tan x, which is sine x, over cos x. So that's another reciprocal identity. Now on the bottom, we are dividing by a 2. But that is the same thing as multiplying this whole binomial by 1/2. So sometimes it's a little bit easier, instead of having a stacked fraction or a complex fraction, just multiply it by the reciprocal. Now on the left-hand side, you can see that it's quite simple to look at right now. There's, we could apply one of the identities here, but when you're proving identities, try to simplify the more complicated side. So for now, I'm actually going to leave the left-hand side exactly the way it looks, so cos 2x over sine 2x, and I'm going to go ahead and manipulate and rearrange the right-hand side instead. So as you can see here, I want to subtract two fractions with unlike denominators, so I have to make the denominators the same. So for this, the first fraction, I need to multiply the top and the bottom by cos x. Okay. The second fraction here, you'll see that I had to multiply the top and the bottom by, this time, sine x. So sine x on the top and sine x on the bottom. And of course, we still have that 1/2 that sits out front. Okay, so once again, I'm going to go ahead and leave the left-hand side as is and rearrange the right. So cos x times cos x is just simply cos x squared minus sine x times sine x, which is just sine x squared. Okay, and this is all over a common denominator. So I just went ahead and simplified by subtracting those two fractions. And of course, we have a 1/2 that sits out front. Okay, so just looking at this, you may notice here that the top here, cos x squared, is the same, cos x squared minus sine x squared is the same expression as one of our double angle identities. It is the same as cos 2x. So I'm going to replace that expression with a double angle, so cos 2x. All right, now on the bottom, since we are multiplying fractions here, I'm just going to go ahead and multiply straight across. So on the bottom, I'm going to put that 2 right in the front here. So I get 2 sine x times cos x. And you may look at this expression and see that that also matches another double angle identity. And that matches the first one, the sine to the double angle identity for sine. So 2 sine x cos x is the same thing as simply sine 2x. And so you'll see this right-hand side now matches the left-hand side. So I didn't have to manipulate the left-hand side here. I just kept it the same, and I just chose to simplify the more complicated side. And I believe my proof is now done.